let's go. I am going to talk about a couple of things. One is an update about JavaScript, and another is about my experience at Brave, which I hope will be of interest. It's not exactly fintech, but there are some points in common. So I've been doing standards a long time. People complain about how long it takes to do standards. I did a standard once in 10 days, and I never hear the end of complaints about how I made mistakes rushing it. So I think people should rather standards take longer. I think it's better if standards take longer. Not too long, no stalling, no monopoly funny business that required Firefox to restart the browser market, things like that. And that's one of the reasons I've got some milestones here, like Bitcoin and Ethereum, because these are new, peer-to-peer networks with properties of money that are unleashing innovation, hype, all sorts of things, human things, without a lot of gatekeepers and without a lot of waiting around for standards. And that's kind of cool, but the web is mature, and there are standards, and JavaScript's one of them. And it's been a standard since 1997 when ES1 was standardized. In September, it was finalized. That was the first edition of the ECMA standard. ECMA is a strange name. It used to be an acronym for the European Computer Manufacturers Association. It's now just a noun, ECMA, capital E. They wanted to be global. They didn't like being just European. And I gave a talk at PXGS in 2011 where I talked all about ECMA and philosophy and how the standards committee actually works well together, and when it goes wrong. I use the good, the bad, and the ugly as my metaphor. You can find that on my friendandive.com site. It's worth looking at. There are definitely ways the committee can go wrong, but it's working pretty well now. It's a fairly balanced committee. It's big, and so we've added big int to match the size of the committee. Everyone who uses JavaScript after a while realizes that the number type is really just a finite precision binary floating point format. It's the one that's in our hardware. IEEE 754 is the spec. It was based on work in the 70s, led by Professor Kahan and others. It's here for the long haul, and it doesn't always work right in the sort of decimal arithmetic sense you're used to from when you were a kid in school. So the famous example is 0.1 plus 0.2 equals 0.300000000000000, I think 0008. And that's how binary rounds. It's a decimal. The two are not equivalent. You cannot represent all fractions, especially powers of 5, with powers of 2. So you have to round, and when you round, you get funny results like that. People also realize that JavaScript, with this funny single number type, has a limit on how big numbers can get before you start losing precision. You get things sort of chopped on the right end of the bit string so that you get the wrong answer. And even though you can go into exponential notation and get pretty large, IEEE 754 double is big, you lose precision. So big int makes up for a lot of this, and it's actually at stage 3 as of the July TC39 meeting, which is good. We can do with this proposal, which is going to be implemented this year, I think, and into next year in the top engines. Championed by Dan Ehrenberg, formerly of the V8 team, now Igalia, Spanish open source consultancy. Dan's just a terrific hacker and leader in TC39, one of the new generation, and he's championed a lot of proposals, and he's taken on big int. I helped get things started because, believe me, we've been going around the block on adding int64, uint64. Some of you who are at FinJS in New York last year might remember my talk. I used that as kind of a trick to get Dan to go do the real work of doing big int, and it worked. I didn't really have a strong preference to do 64-bit integers because while their machine types, they obviously have only 64 bits of precision. And so Dan and others felt strongly that we should have just an arbitrary precision integer, and then we can make it fast for 64-bit use cases. And it has, what you want, this nice literal syntax, the end suffix. It has ways to cast between different fixed bit size of integers. And it has some protected features. You can't mix it without a type error with numbers, the battle IEEE type. That'll throw a type error, except for less than and equals and things like less than or equals. That works because it's safe to compare a number and a big int. They can be put onto a larger number line without loss of precision or loss of transitivity or other properties you want. Big int is also useful for JSON. When Doug Crawford did JSON, he had this idea that the JSON numeric literal would have as many digits as you want, and it was up to the endpoints to agree on what it meant. Well, it turns out when people connect things, they often use programming languages that have definite ideas, like JavaScript, that the numeric literal is an IEEE double, so it doesn't actually have enough precision to represent an arbitrary number of decimal digits. Whereas something like Python, if you use Python's big int type, which is called long, I believe, or Ruby, if you use the right type, does have arbitrary precision. And so you can get these strange protocol errors. I think Twitter has been through two Twit-apocalypses. The first one was when they had 32-bit identifiers, 32-bit integers for identifiers. For some reason, they thought that was enough, and it wasn't. And as that number started to wrap around, the Twit-apocalypse was upon us. And then they switched, I believe, to JavaScript numbers, which only have 53 bits of precision. And so the second Twit-apocalypse came, and then they switched to strings. And you can still find JSON APIs from Twitter where the endpoint allows you to set an ID as a string and as a number. And sure enough, Twitter IDs are not big enough that you lose precision on the right end of the number. You get it truncated to the lower power of 2. If it's sent as a number, whereas the string carrying all those decimal digits has the full very big number. So big numbers would be handy for JSON, but you have to opt into them, you have to know what you're doing, your endpoints have to agree. And typed arrays, which you may know about from ES6, that came in by way of WebGL, very handy ways of dealing with memory as a packed array of machine integers. We'll have big N64 array, big UN64 array that allow us to deal with the 64-bit machine types, but read them into big ints, which is important, and write big ints into them. Data view is a related type from typed arrays. So this all makes sense. There's an explainer, spec, and issues links. I'll try to get these slides on my site. And here's an example. If you write a Fibonacci generator function like this, generates the nth Fibonacci number, where by convention the 0th Fibonacci number is 0. If you do it with just 0 and 1 as the seed values in that array literal, where you see 0n and 1n right now, you'll find that you'll get the wrong answer at fib of 79. You will lose precision, as I mentioned. You'll get a 0 in the last place when you should get a 1. So big int right away will be useful when you start getting to this larger number, which you can easily get to through things like, I don't know, fintech, machine learning, stuff like that. Here's an example of ASM.js, which was the precursor of WebAssembly that I was part of at the executive sponsor level at Mozilla, getting through all the other browsers and helped get WebAssembly off the ground. And it's still useful to experiment with extensions like this add64 function. This shows how you would do a 64-bit math operation in sort of low-level WebAssembly like code, ASM.js code, you know what that is. And it uses that big uint64 array. I mentioned it uses that cast operator as uint_n. So there are ways to do 64 math. They aren't pretty. The idea is that if you really need them, you'll get library routines, or we'll make it possible to add value types that users define. Possibly we'll add a 64-bit type anyway. There's debate in the committee over whether we add big int and then make everybody else do it through library code, or we keep adding numeric types, which we might do. I don't know. The committee will have to ponder that in its philosophical way. And I guess I could say a few more things about ECMA at this time. The committee's also doing things that if you use ES6 classes, you'll like public fields, also private decorators, things that you're used to from Java if you have classes or from a sort of a TypeScript world. There are things like a new date time module, the temporal module, which fixes all the problems we know and hate from the old JDK 1.0 Java util date class that I had. That was the one thing I had somebody at Netscape help me with in the 10 days sprint. I think it might have been after that, but they finished it. They took James Gosling's Java code for date, which had Y2K bugs, and they translated it straight into C, and I put it in my first JavaScript engine, and we've had Java date objects ever since. When we standardized ES1, we fixed the Y2K bugs as much as we could. We left the legacy get year, two-digit year nonsense behind. It's still there. But now we're finally getting modern sort of Jonah time, date and time, civil dates, instance, zoned instance, everything you want. So that's cool. And there is a connection with this blockchain section I'm now going to switch to, which has to do with the language used on Ethereum called Solidity. But hold that thought. I'm going to talk about the predicate problem that led us to work on the blockchain. And that's a lot of you probably experience this. Some of you may even use Brave or a competent ad blocker like uBlock Origin. I hope you do. Ads have gone wrong. The web was not designed to have ads or tracking. They evolved. And they evolved in a way that is parasitic in a biological sense. It costs users actual money, like $23 if you're untiered data plan, half your data plan probably, estimated by New York Times, with some extra work by Rob Leather now on Facebook, goes to loading trackers and ads. And it's not just the ads you see, it's the invisible scripts, JavaScripts, my fault, right, that get used from third parties to measure you and put you in a real-time bid, figure out what ad to put in a slot on a publisher page. In a real-time ad exchange, Google has a big one. They also have the biggest ad server. This system is just bad news. It not only is taxing users parasitically in real dollars and cents, draining your battery as it runs the radio to load these scripts that lead to the ads, it's also allowing malware into the exchanges because, hey, they get fees in the exchange no matter what they're conveying through it. They allow fraud on the other side where real ads get placed in fake sites, clicked on by fake users, and defraud the marketing side of the ecosystem. Ransomware is the new kind of malware that's getting through ads. It's bad. So our view of Brave is we should block it. There needs to be a better web. And this is hard for big browsers to do. Some of them are owned by advertising companies. Some of them are owned by companies, public companies, beholden to advertisers and publishers. And I understand they can't just go, break advertising overnight, especially if they might get an antitrust trouble for proposing a new system that they have an advantage at. But we're going to do it at Brave. We're doing it. And that's why we started doing some blockchain work. Here's a picture of Ghostery tracking graph for a top media site, TMZ. On the left and on the right is what it looks like in Brave, except actually this slide shows Google Analytics. We've blocked that too. Google Analytics is now fully integrated into the Google Panopticon. It's a tracking system. It helps you measure your site performance, but it's not just like studying your HTTP logs. It actually is putting all that data into the Google cloud where it can be used for other purposes. So we block it. Quite a difference. This is one of the reasons why there's a great savings. That means that Brave is faster, up to 7 times faster on mobile, and that's important on Android, especially where with Chrome on Android, there's no way to block ads. There's no extension model. For various reasons, perhaps commercial, perhaps because extensions for browsers are themselves troublesome, but you just can't do it. You have to get a separate browser like the Samsung browser and configure it with an ad blocker. Brave does it all out of the box, makes it simple and easy to use. We do end-to-end testing. We're adding machine learning to the browser that's totally private. It runs very light CPU load. It's just naive-based sort of stuff to manage exceptions and block things, and saves you money and saves you time. Here's a comparison chart from early this year showing the difference. Shorter is better, orange is Brave, blue is Chrome. There's basically no comparison. If you aren't using Brave on Android, you should try it because it's based directly on the Chromium code. So it's like Chrome, but no ads. No third-party ads, no tracking. We're going to use that machine learning I mentioned to automate fingerprint protection and other means of protecting your privacy and protecting your data. And we have a larger mission beyond just blocking. Because we know, as I mentioned, that blocking ads deprive some publishers of whatever revenue is left over after all those parasites have taken their cut. There's some, problem with getting paid if you're running a website and you need to support it with ads. You can't necessarily get everybody to subscribe. You have, I'm not advancing to the next slide. Hope I'm not stuck on this slide. Let me see if I can fix this. Is everyone seeing the comparison tables for Brave? There we go. Took a while to advance. Let me manually fix that. So yeah. We know blocking ads is destructive, but we think it's the right thing to protect your data on your devices. If you look at this picture, this is a picture of the Lumascape, so-called. On the left are the marketers who buy ad space. They do the gross spending. On the right are the publishers who hope to get whatever's left in the pie tin. And in the middle are a bunch of parasites, the middle players and giants who take cuts out of the pie. And they're taking too much. And there's a huge fraud problem I mentioned. It is estimated to go to 16 billion this year, and nobody really knows. Ad spend is over 80 billion in the US this year on digital ads, just in the US. It's 200 million globally, 200 billion actually globally, billion. And I see something taking its time shifting out of this one too, so sorry about that. I'm seeing a Mac beach ball now, the dreaded beach ball. I think it's my screen sharing. So we want to replumb the valid parts of this Lumascape, which are the marketer on the left, the advertiser, the publisher on the right. People will have to keep the lights on or there won't be any web. And the user as the mediator. We want to take all these parasites and the superpowers like Google and Facebook out and put you in the middle using the browser. Because that's how ads are placed now. They're already placed using JavaScript. That's kind of the secret shame of mine. That people think, oh, ads are maybe like ink on paper on the publisher site, or they're somehow materialized in a way that happens server to server. No, there's always a script that runs. There's always a cookie or some equivalent means of tracking you across sites to get better ad deals than an individual site could get. And that means that the user running the browser, again, paying the data plan bill, paying the battery price, is supporting a bunch of scripts that do a very inefficient and risky, in terms of malware, job placing ads. We think the browser could do it privately, and that's what we are building in Brave. And we looked at the blockchain to manage the payment side of it, since you can have, in theory, low overhead and high volume and even anonymity, like Zcash is working on, has in their blockchain. And there's no perfect here, but we invested in the blockchain for these reasons. And it certainly beats, something like using fiat currency, where you might have to be a money transmitter and get a money transmitter license, or having, other sort of regulatory complexities, hooking up people's bank accounts directly. With cryptocurrency on a blockchain, you can, with enough user interface work, make it convenient. With small amounts, you can let the user hold custody of the funds. And I've got a bad beach ball problem here. Apologies for that, but it seems like I've got a map that's on. Let me see if I can get out of this again. Can anyone hear me? Can you still hear me?
Yeah, we can hear you, Brendan.
Yeah, I'm definitely stuck, not advancing. I think it's Keynote that's beach balling, and since I'm full screen, I cannot force quit. Does anyone know the Vulkan death grip? Is it like Alt, Command, Delete? Is that right? Is it Control, Command, Delete?
I think it's
Command, Option, Delete.
Yeah.
I'm just going to hold it down. Yeah, I think Skype.
Do you want me to hang up and call you right back?
It might help, but I'm pretty sure this is Keynote because it's the full screen foreground. Hang in there. Let me just hold this down and see if it works. If not, I might have to press my power button. It worked. All right. Let me see if I can get onto the next slide. I suspect Skype and Keynote are using all the memory on my system. So let me go to the next slide. This just shows ad blocking adoption is going up and up and up. And I'm going to avoid full screen until I really need it. This talks about the basic attention token, which is the token we built on the Ethereum blockchain and cryptocurrency system, and we did it this year. We had what's called a token sale on May 31st. It was successful. The idea of this blockchain-based digital advertising is to mediate, as I said, between the advertiser and the publisher and the user without any intermediaries like the Googles and the Facebooks and the App Nexus Rubicons of the world. Nothing wrong with them except that they're taking too much money out, they're letting malware in, they're taking away your data and your battery and not giving you much in the way of just compensation. Our token sale, this might be of interest to you fintech people, was what's called a capped sale. It's a very simple smart contract. Ethereum, unlike Bitcoin, has a Turing-complete scripting language on the blockchain, so it's running with a peer-to-peer network. It's running the same code on thousands of nodes around the world to reach consensus. There are definitely some engineering issues here. I mentioned earlier that they took JavaScript as a superficial inspiration for the smart contract language that's commonly used. There are several, but the one we used is the big one, Solidity. It's called Solidity, I guess. On Ethereum, things might be ephemeral, but Solidity is based on JavaScript, at least syntactically, and it has only one numeric type. It's not the IEEE double type. It's not big int. It's a 256-bit integer, and that has its own issues. But we used it. If I were to do a smart contract language, I would want something much different. Dan Bonet of Stanford has made the argument better than I can that you want sort of a state machine language that's functionally pure. You want to avoid this Turing-complete, arbitrary control flow just to check a condition to advance from one state to the next. You can do that with a functional pure language much more efficiently and safely. You don't have to worry about all these dead states that people accidentally write when they write smart contracts, as if they were writing JavaScript code. Our contract was simple, and we knew the simplicity was going to keep us from having too many dead states or other problems. We also had 3 great auditors, professional auditors we paid to look at it. We still had this weird oversight where people to buy the bat on the day of the sale would send us ETH, the ethers, the cryptocurrency of Ethereum, and they would get back on the return address. Sounds good. For some reason, people sent us BAT or some other token instead of ETH. And we didn't implement the right method or override the right method to flag this. And so that token or tokens that were sent to us by mistake are stuck, frozen at the edge of the event horizon. They can never be refunded. We can't do a thing about it. Because the blockchain is immutable. And once the smart contract mutates by advancing the blockchain, there's no going back. So we didn't think of that. It turns out some other token sales before us, we should have looked closely at, had the same mistake. People just sent tokens instead of ETH. It's just a mistake people make. And there's no way to do anything about it. It's not refundable. The token model we're using is a utility token. It has a utility for sort of unlocking an API on a platform. In our case, it's like ad slots, private ad slots for the user. We sold 1 billion tokens out of 1.5 billion total, so we pre-created tokens, including a user growth pool. We can think of this as a social credit currency system of sorts. And that something you can't do without the Ethereum token system. If you tried to use Bitcoin or Ethereum as the cryptocurrency, there wouldn't be any user growth pool unless some money bags donated that much, that many millions of dollars to fund that pool. So by fiat, we created tokens for users, which we will be dispersing as this platform comes up in order to gain user adoption, reward users for passive uses by the ad tech system, and match their donations to sites. Because we believe, this is something already engraved, that people should be willing to donate, or if they are willing to donate, they should be able to donate anonymously to their top sites and do that in lieu of seeing ads. We did the sale so fast, we clearly could have gone a lot bigger. We sold all our tokens, 156,250 ETH was raised. 1 billion tokens were sold in 24 seconds, 2 blocks on the Ethereum blockchain. I talked to some fintech guys in New York who were participating as buyers. They had a special sniping rig they built, special software they built. And if we had gone bigger, we would have had more buyers. But it turns out over 3 months, it's diffused among 11,000 different addresses on Ethereum, so we're not seeing anybody corner the market. And we did so well, we kind of kicked off or accelerated something that was already happening, which is the token phenomenon. We're in the top 10 list, but we're the most modest. We didn't go big. Some after us went bigger. Some of them I admire, like Tezos. Some of them I'm not sure about. But this is the new frontier. This is the new world. As I said to Joe McCann when we did our sale, burn the boats. The VCs in the Valley are looking on with interest and some amount of fear. That's good. Okay. What are we doing with the token? We're making a platform. This was promised by Brave since we launched it. We're not just blocking ads. If you want to opt in, so we'll not be imposed on you. We'll not be imposed on publishers. But if you want to opt in, you can donate your top sites anonymously. If you try to do that with something like Blendle or Flatter Plus, it's not anonymous. Your donation list is on the server. The terms and conditions I've read say that they own that data. That data fingerprints you, and they can use it to profile you and build up a tracking business if they choose to, or sell out to Oracle, as so many of these ad tech companies do, or Salesforce or IBM. So we have a model that's much more deterministic. We use zero-knowledge proof protocols. We have a deterministically anonymous system for donations. We also can use that for ad confirmations. So in the later phase of our system, we're going to add personal ads or private ads. Think of these as like WeChat one-a-day promotions that you can get if you use WeChat. For a chatbot, we're thinking about doing them in private tabs, very low frequency at the right time and place for you, long-form video ads, and you'll get 70% of the revenue share. Because there'll be no publisher to pay. This is your ad and your ad slot. This is your inventory, as they say when we talk about ad space. And we're going to try to get users to opt into this. It's not like they can get a lot of money out. And to get the money out, they have to go through a KYC procedure so we don't get defrauded. But we expect a lot of users will just make the ad revenue in order to fill up their token wallets and then donate it back to their favorite sites. So we're hoping to sort of transport the good parts of the ad system that funds much of the web and donation systems that are not anonymous into a browser-centric anonymous system that pays the user and then gives the user control. Here's what the panel in Brave settings looks like for donations or contributions. We already have this prototype with Bitcoin, and we're working feverishly to get it switched to the token this month. And you can, again, opt into it. It's not on by default. There's no extra scariness. It's all local. There's no remote tracking. There's no server. Your browser's already aware of your history, so you're not giving your browser any more information than it already has, and it actually stores locally. But this view of your history allows you to then anonymously vote for sites, as it were, and give them shares of a monthly budget. If you wish, you can even pin donations. You'll see two sites that have a little push pins on the right there in the middle, and those get money whether you browse them or not. The rest get money pro rata based on your browsing behavior. We exclude software as a service sites and other sites that aren't really human content that's published or curated. We also exclude the big content platforms like YouTube, because we'd like to pay the YouTube and Twitch account holders, not the feudal lords of the manor. And so how does this anonymity work? It requires the zero-knowledge proof protocol I mentioned. It currently, in the early stages, requires some hybrid centralization and decentralization. So we use the blockchain for gross aggregated flows of money. We can't, currently scale microflows, and they aren't anonymous anyway. So we do batching in the browser, and after 30 days, the payments flow, and nothing is re-identifiable. We use our own accounting server, currently centralized, it's open source, it's written in Node.js, to do the zero-knowledge protocol and to do the sort of set reconciliation and settlement to the publishers. We have 180 publishers on board, and we're bringing a bunch more in. We have over 130,000 user wallets that are already created with the Bitcoin prototype. So we're already going at this as just a baseline, fast, protected, blocking browser that gives you these options that will getting good user adoption. We have a partner, Uphold, which allows you to exchange the token if you go through KYC. As I mentioned, we're not going to be easy marks for fraudsters, but Uphold helps exchange BAT tokens with fiat currencies. We also hear from people who still want to use Bitcoin to fund their wallets. Uphold has that option too, which is cool. It looks like I can't play this unless I hit play and go try it. Wish me luck. Here we go. Animate GIF. So I'll fold. Yeah, it's beach ball. I think this is my last slide before Q&A. Anyway, what have I learned about the blockchain? It is the Wild West, or early days. I wouldn't be surprised if in Q&A, if in 10 years we're all using the sort of the redheaded love child of Bitcoin, Zcash, and Ethereum. I think value will be conserved. I think people will figure out how to migrate, like flocks of birds or dinosaurs. I think the money that's flowed into the system and then appreciated with the run up in Ether in particular over the last year, and Bitcoin, of course, too, is not going to go away. It's not going to go to zero, and it's definitely the new way to innovate without lots of gatekeeper permission and lots of sort of conservatism that's built into the old world. So I can't say enough in this talk about the details of how we did this because it's tricky. There are unknowns. There are all sorts of accounting and legal complexities, but we had top advice from Deloitte and Perkins Coie, and we are confident we have a robust system that we're going to bring to fruition over the next year and a half. And we hope people will try it. We hope to influence web standards, as I mentioned at the beginning of my talk. They take longer. The impossible just takes longer. And so the story of my life continues, and big hits are coming. And what else can I say but always bet on JS? Thanks very much.
Brendan, can you hear us on the mic?
Yes, very well. Thank you.
Okay, terrific. So we're going to take a few questions, and then we'll go to drinks. I will hand the mic to anybody who wants to ask Brendan a question.
Hi, Brendan. Back when you wanted to put Scheme into Netscape, were you thinking about taking a Scheme off the shelf or making one yourself?
It was really a bait to recruit me, and there wasn't a good open source Scheme culture then. I think Guile was fairly new, and Netscape didn't want to use GPL code. It never got anywhere near me looking at options among the Scheme engines. Shea Scheme might have been around too. Can't convince one. The Scheme was just sucker bait to get me in Netscape. And once I got there, I was like, whoops, we're doing a deal with Sun to do Java in the browser. And Andreessen was saying Java plus Netscape kills Windows. He was saying it loudly to everybody, which helped Microsoft, target him. And then I had to work with Mark and Bill Joy to get others to believe that there should be a second language, the sidekick language, robbing the boy hostage, in Frank Miller's famous phrase, to Java Batman. And of course, Java died in the client, never got out of the plug-in jail, but there was no chance for Scheme. It was just recruiting bait.
Brendan, I have a quick question. Can you say how much money got kind of like orphaned in your ICO?
Oh, the tokens that were sent by mistake to our sale address? It was small. I mean, that was just a mistake somebody made. At first, we weren't sure if they were trying to, trick us or defraud us, because that happens. A lot of scamming, a lot of trolls. But it looks legit, but it was small. There was no orphaning, but there was certainly competitive bidding in those 24 seconds. And so people were spending on the fee. It was called gas. It's a basis point fraction of Ethereum. And the gas charges went high, and so people who got in on the sale had to spend a lot on gas. That's how Ethereum works. That's how it manages, to share all those peer-to-peer nodes and be resistant to denial of service and spam attacks.
Any other questions, Brendan?
Hello? Okay. Hey, Brendan. I think Brave is a great idea. I think most people would agree, but the question I have is, do you have a plan for how this might go into the mainstream, like, say, Netscape or Firefox have?
Netscape, that went mainstream because it was better than Mosaic. I think one of the things that we've seen over the years is people just think the browser market or any mature market cannot be cracked, especially if it's monopolized. Like we did Firefox, and conventional wisdom, especially in the Valley, was, the browser's over. Like Microsoft cornered the market, and it's done. But of course, what Microsoft did was they got prosecuted successfully for using their monopoly, and they really wanted to go back to Windows lock-in. They kept doing this Poor Me Act 15 years ago about how, oh, the antitrust case is so mean and web standards are so hard. Let's just do Windows Vista. That'll be great. We'll just lock everybody into that. And they really missed the boat. Not only did Vista kind of not do well, but they missed the smartphone, they missed the iPhone, and they missed what we did with Firefox, which was to actually make the browser really good, because IE was not good. IE6 was down to a skeleton maintenance crew. So Chrome doesn't have a maintenance crew. It's arguably got too big a crew, but Google will not block ads. So what's happening in the world is ad blocking is rising. I had a chart I had to get through quickly because I was getting beach balling, but it showed 660 million users globally using ad blocking, and that's with the hardship of finding an extension and matching it to a browser and configuring it and all that stuff. Brave works out of the box, and we're hoping we're going to get, multiple millions of users. We have line of sight, we think 5 million users next year. We will go as big as we can. And we also note, as Ness and Nicholas Taleb and others point out, you don't need the core of the market to influence it. 3% can do it. It's why all salt is kosher and halal. We don't make 2 kinds of salt. It doesn't make sense. We're going to move the web standards toward privacy. Apple is an ally here because they are the best among the big 4 in terms of privacy. Also in Europe, there's something called GDPR and something else called e-privacy that's coming along fast. In one interpretation, these things ban tracking. They make tracking require consent. There may be no other GDPR compliant browser than Brave next year, and that could help us in Europe a lot. But again, we're not trying to take over the browser market, we're just trying to influence it, maybe exit to one of the bigs, because as I noted early on, the bigs can't do what we did. Even if they wanted to, even Mozilla is too conservative and too, captured by its search partner or partners. We can do that. We can sort of clean some of the slate and show a better path, and then help other browsers use it. And that's one of the things we want to do with the BAT. The token is not just for Brave. If we can get the BAT and the endpoint rules for it that are encoded in Brave well specified, we can bring it to other browsers, other attention apps, games, have ads in them too, could have donations. Anything creative, the AR, VR world that's coming fast, messaging apps also. So we're looking to make it truly the basic attention token. And if we do that, I think there will be emerging standards around privacy. Because when you think about the 90s, the accidental innovation of tracking came out of the image, the cookie, and JavaScript. They were not intended to be used for ad tech. And we stopped standardizing. We didn't standardize things like a tracking pixel or an ad or anything declarative or easily blocked that could have been codified by standards. And it wasn't in the interest of all the sort of evolutionary fast movers who innovated in ad tech to go standardize any of that stuff. Now probably is time, especially with GDPR and privacy in Europe. Google is also under antitrust investigation in Europe. This is not going to go away. And ad blocking adoption is not going away. It's rising linearly in the US. I think it'll go even faster on mobile if we can have any say in the matter.